Welcome back. It's still your video mathematics tutor, Emmanuel Johnny. I want to believe you are really enjoying the teaching because even me myself, I'm enjoying myself teaching. So you have no reason not to enjoy what I'm teaching you. Now we've done the introductory aspect of this. We've seen how to solve quadratic equation by factorization method. I really took time there to explain extensively. Here in this video 3, still under quadratic, I'm going to be teaching us how to solve quadratic equation by completing the squares method. So let's get started. Okay, before I dive in deeply, now don't forget that in factorization method, I started by saying that x squared plus 7x plus 10 equals to 0. And when we were done solving, by the way, at the end of my teaching, I'm going to show us some shortcuts to arrive at the answers. But for now, let's keep going with the long cuts. Here, what did we get as our values of x? X was equals to minus 5 and minus 2. These were the roots of the equation when we solve by factorization method. Now I'm going to be solving this same problem by completing the squares method. But before I start, let me teach us or take us through a journey that will help us when we start solving proper. Let me begin like this. If I have an expression x squared plus 4x, now a very simple question can be asked. What must be added to this expression to make it a perfect square? Now I have introduced a word there, perfect square. Let me make us understand this. What I mean by perfect square is this. 4 is a perfect square. 16 is a perfect square. 25 is a perfect square. Even 9 is a perfect square. Question: why do we say that these numbers are perfect square? Answer: because the number 4 can be written in terms of power 2 as 2 raised to power 2. 16 can be written as 4 raised to power 2. In other words, 2 times 2. This one now is 4 times 4, 16. 25 can be written as 5 raised to power 2. And 9 can be written as 3 raised to power 2. So any number that can be expressed in terms of power 2 is called a perfect square, or you say square number. 8 is not a perfect square because I cannot write 8 in terms of power 2. Rather, it can be 2 raised to power 3. So this is perfect cube. So any number that can be written in terms of power 2 is called a perfect square. Okay? When I say what must be added to this expression to make it a perfect square, you understand what I mean by understanding this concept. So let me make it clearer. Now, I will say that what must be added to this to make it a perfect square is the number 4. That's the answer. How? Very simple. These are steps to take to get to that number, answer 4. Step 1, ask yourself, what is the coefficient of x? The coefficient of x is 4. So bring out that 4. Look at it here, 4. Step 2, what is half of this number 4? We know that half of 4 is 2. That is half of 4. Half of 4 in mathematics, the word of means multiplication. So take half of 4. This is 1, this goes here 2. You can see half of 4 is 2. I go over it again. Step 1, what is the coefficient of x? 4. Look at it. Step 2, what is half of 2? That's to say 4 divided by 2. The answer is 2. Step 3, square that answer. You square it. What is 2 squared? It is 4. So this is the answer. So plus 4 must be added to this expression to make it a perfect square. Okay, I take another one. If I have x squared plus 8x, what must be added to make it a perfect square? Step 1, what is the coefficient of x? 8. Half of 8, that is 8 divided by 2, that gives you 4. Next, square that 4 and you have 16. So plus 16 must be added to make it a perfect square. Or you can write it as x squared plus 8x plus, put this 4 squared, which is the same thing as 16. Okay, I give you, if I have x squared plus 3x, what must be added to make it a perfect square? Step 1, what's the quotient of x? 3. So look at it, 3. What is half of 3? 3 divided by 2. Now this is different from when we had 8 over 2, 4 over 2. Because this one, 2 goes here, 2. 2 goes here, 4. But in this case, 2 goes into 3. There will be a remainder. So what do? Leave it at this point to be 3 over 2. The next step, you do what? You square it. So that means that if you square it, that is 3 square is 9 over 2 square is 4. So 9 over 4 must be added to make it a perfect square. I want to believe that this point is clear. Now, let's learn something else that will still help us in the journey of this subheading. Having known that, so we have said that if I have x squared plus 4x, what must be added to make it a perfect square? We said 4, which is 2 squared. I added 2 squared to x squared plus 4x to make it a perfect square. If that is true, remember what I said, that if I have a number 4, that this number is a perfect square. Why? Because I can write it as 2 raised to power 2. Which means that if I have 2 raised to power 2, 2 raised to power 2 means 2 times 2. And it will give me what? 4. That means if I expand this, 2 raised to power 2, which is 2 times 2, I must get 4. Meaning that this is the index form of this perfect square. When I expand the index form 2 raised to power 2, that is 2 raised to power 2, meaning 2 into 2 places, 2 times 2, I obtain my original number 4. So which means I broke down 4 into 2 raised to power 2. If I expand it back, this 2 raised to power 2, I obtain back my number 4. If that is true, let's do something here. So remember, I gave you something and I said x squared plus 4x. What must be added to this to make it a perfect square? And we said x squared plus 4x plus. We say if we add 2 raised to power 2, which is 4, to this, it makes it a perfect square. If that is true, if this number now, you have agreed that this is the perfect square of this number, just like this is a perfect square of this number, then if we say that this is a perfect square of this number, it therefore means that this number, if it is in perfect square, I can write it in terms of power 2. 4 is a perfect square. Why? We can write it in terms of power 2 as 2 raised to power 2. Now, this number, this expression is a perfect square because I can write it in terms of power 2. How do I write this in terms of power 2? Step 1, bring out 1x here, plus, bring out 2 here, plus 2. How many x is here? 2, I brought out 1. How many 2? 2, I brought out 1. I will raise it to power 2. This is a number. Now, just like we have 4 as a number. In index form is 2 raised to power 2. So this is like the number, for instance. Then the index form of it is x plus 2 raised to power 2. So this becomes the index form of this perfect square. Just like I could write 4 as 2 raised to power 2. That's how I have written this now as x plus 2 raised to power 2 in its index form. Now, it means that I have been able to reduce the whole of this into this in power form. If that is true, it therefore means that if I expand these brackets, I must get everything here. Just like I expanded 2 raised to the power 2 to get back 4. So if I expand the whole of this, I should get back everything here. So let's go there. This is x plus 2 times x plus 2. Just like we have this to be 2 times 2. So into 2 places, x plus 2, x plus 2. So this is equals to x times x, x squared. X times 2, 2x. 2 times x, 2x. 2 times 2, 4. So this is x squared plus 2x plus 2x, 4x plus what? 4. So expanding this gives us back the whole of this. So that is exactly how to write this in index form. So you can see that by the time we expand this, we obtain this back. So this is now what? The perfect square of this. Okay. Having understood that, it therefore means that if I have x squared plus 8x, one must be added to make it a perfect square. You add half of this is 4, then you square it, and that will be 4 squared, which is 16. It means that if I want to write it in index form, I'll take 1x plus, take 4, then raised to the power 2. If I expand this, I'll get back this. Now this understanding will really help us. Okay, if I have x plus 3x, x squared plus 3x, remember the coefficient of this is 3. Okay, half of this now is 3 over 2 raised to the power 2. So that means 3 over 2 raised to the power 2 must be added to this to make it a perfect square. And if I want to write this in its index form, I'll write this to be pick 1x plus pick 1 3 over 2, 3 over 2 raised to the power 2. Meaning that if you expand this, you get back the whole of this. So having done this, we are going to apply this thing I have taught you now in solving quadratic equation by completing the squares method. Okay? An example is this. We have solved this problem already by factorization method. Now we are going to solve it by completing the squares method. So let's start. If I have x squared plus 7x plus 10 equals to 0, I want to solve this by completing the squares method. Step 1. Take the constant term. Okay, make sure that the coefficient of x squared is 1. So at this point, that point is satisfied. Step 2. Move the constant term to the right hand side. So we have x squared plus 7x equals to minus 10. Remember, plus 10 will cross to become minus 10. Step 3. Now, have you seen what we have here, which is equivalent to when we started with like x squared plus 4x or x squared plus 3x? And we say what must be added to this to make it a perfect square? 2 terms. What must be added to this to make it a perfect square? That's exactly what you are seeing here. X squared plus 7x, which is 2 terms. So you ask yourself, what must be added to this expression at the left hand side to make it a perfect square? Then, so we have x squared plus 7x plus, what must I add? Step 1, what's the coefficient of x? 7. Step 2, divided by 2. Step 3, square it, raised to power 2. So that means 7 over 2 raised to power 2 must be added to make it a perfect square. Then, okay, let me do this. The coefficient of x is 7. Look at it, 7. Step 2, divided by 2. That's half of it, divided by 2. Step 3, square it. So 7 over 2 squared must be added to the left hand side to this to make it a perfect square. So you are going to add that 7 over 2 raised to power 2 to both sides of the equation. Okay, so we have x squared plus 7x plus 7 over 2 squared equals to minus 10 plus 7 over 2 squared. Add it to both sides. Okay. Now look at the left hand side. You can now factorize it like we did. So x, you pick one x here, plus you pick 7/2, 7/2, everything raised to power 2 equals to minus 10 plus 7 squared is 49 all over 2 squared is 4. So that x plus 7/2 all squared equals to, now this is fraction, so we're going to deal with this fraction. Okay, you find the LCM. The LCM is 4. Now this is over 1, this primary 4. 1 goes into 4, 4 times minus 10 minus 40. 4 times minus 10 is minus 40, plus 4 goes into 4, 1 times 49, 49. So you have this to be, what is minus 40 plus 49? Please, by now you should know that the answer is 9. Minus 40 plus 49 is 9. So you have 9 divided by 4. So having simplified this place, you have 9/4. So you are going to have x plus 7. X plus 7/2 squared equals to 9/4. Having simplified this fraction, 9/4. So I'm looking for x. Now don't forget that this square will move to the right hand side. So you have x plus 7/2 equals to, when this square crosses, it will become plus or minus square root of 9/4. Don't forget. So at this point, x plus 7/2 equals to plus or minus the square root of 9 is 3 all over the square root of 4 is 2. Okay. Now x is equals to, take plus 7/2 to the right hand side, you become minus 7/2 plus or minus 3/2. So at this point you can say that x is minus 7/2 plus 3/2, or minus 7/2 minus 3/2. So now x is equals to, of course we told in fraction, if the denominators are the same, add the numerator. So minus 7 plus 3. Minus 7 plus 3 is minus 4 divided by, pick one of the denominators, or minus 7 minus 3 is minus 10 all over, pick one of the denominators. So x is equals to, this goes here, you have minus 2, or minus 10 divided by 2, minus 5. So these are the roots of this quadratic equation by completing the squares method. So I'm going to give us one last example under this for better clarification.
Mathematics.
This example number 2. If you compare this with the previous one I did, you will see that the other one was x squared plus 7x plus 10 equals to 0. Now the coefficient of x squared is 1, no problem. But in the second example, the coefficient of x squared is 6. So what do you do to turn this place to 1? It is by dividing through by the coefficient of x squared, which is 6. So let's go there. I have 6x squared divided by 6 plus 7x divided by 6 plus 2 divided by 6 equals to 0. Now this and this will go, so you have x squared plus 7/6x plus 2 here 1, 2 here 3 plus 1/3 equals to 0. Now next step, take the constant term to the right hand side. So you have x squared plus 7/6x equals to, plus 1/3 will move to become minus 1/3. Next step, what is the coefficient of x? 7/6. So look at it here, 7/6. What is half of 7/6? half, that is 1 over 2, half of, which means times 7 over 6, which is 1 times 7, 7 over 2 times 6, 12. Then square it and add to both sides of this equation. So you add 7 over 12 square to both sides, which is x squared plus 7 over 6x plus this 7 over 12, 7 over 12 all squared equals to minus 1 over 3 plus that's 7 over 12 all squared. Next step, let's factorize the left hand side. Remember, I'll pick one x here plus I'll pick one 7 over 12 and then square equals to minus 1 over 3 plus 7 square, that will give us 49 all over 12 square, 144. So x plus 7 over 12 square equals to, now if you find the LCM, that will be 144. Now 3 goes into 144. That's 144 divided by 3. That will give you 48. 48 times minus 1 is minus 48. Plus 144 goes into 144. That will be 1. 1 times 49 is 49. So this is x plus 7 over 12 square equals to minus 48 plus 49 will give you 1 divided by 144. So x plus 7 over 12 equals to, remember the square will move to become, now we have 144, 1 divided by 144. When this square moves, it will become plus or minus square root. Please note, the square moves to become plus or minus square root of this. Plus or minus square root of this. So, x plus 7 over 12 equals to plus or minus, the square root of 1 is 1 all over, the square root of 144 is 12. This will make me to clean this. Okay, this is x. Look at it here. X equals to, I want to collect like terms. Plus 7 over 12 will move to become minus 7 over 12. Then plus or minus, remember, plus 7 over 12 plus to become minus 7 over 12. It has moved to become this. Then plus or minus 1 over 12. 1 over 12. So x is equals to minus 7 over 12 minus 7 over 12 plus 1 over 12, or minus 7 over 12 minus 1 over 12. With that, we can say that x is equals to, now the denominators are the same, so minus 7 plus 1 is minus 6 divided by, pick one of the denominators, 12, or minus 7 minus 1 minus 8 divided by, pick one of the denominators, so that x is equals to minus 2 here, 3, 2 here, okay, let's go straight up, 6 here, 1, 6 here, 2, or 2 here, that will be minus 2 here, 4, 2 here, this is 4 over 6, 2 here, 2, 2 here, 3, that is minus 2 over 3. So these are the roots of the equation. So that's exactly how to solve quadratic equation by completing the squares method. Now, the next lesson which is going to be lesson 4, I think. I'm going to teach us how to use the general form of a quadratic equation to derive the quadratic formula by completing the squares method. So that's what I'll be doing in the next video. Don't forget, I still remain your video mathematics tutor, Emmanuel Johnny. Thank you.
Mathematics tutorial with